Have you ever noticed how cross everyone gets when the internet's down? It's like the world stops. People can't post pictures of their lunch. It's chaos. That's why keeping an eye on network performance is dead important. It's about making sure things run smoothly, like a well-oiled bicycle chain. Our job is to ensure traffic flows without bottlenecks. Monitoring helps us spot problems before they become major headaches. Now let's talk about network metrics. These are like the vital signs of our network, telling us how healthy it is. First up, we've got latency. This is the time it takes for a data packet to travel from one point to another. Think of it as the ping time in an online game. High latency? That's lag, my friend, and nobody likes lag. Then there's throughput, which is all about how much data can travel over the network in a given time. Imagine a pipe carrying water. Throughput is like the diameter of that pipe. The wider it is, the more water can flow through. Packet loss is another important metric. This is when data packets get lost in transit, like a letter getting lost in the post. It can lead to slowdowns and even data corruption. And finally, we have jitter, which is the variation in latency. Think of it as the internet equivalent of a bumpy car ride. To keep track of all these metrics, we use something called SNMP, which stands for Simple Network Management Protocol. It's like a secret language that lets us talk to our network devices and gather information about their performance. Now, even with the best monitoring in the world, things can still go wrong. It's like that old saying, to err is human, but to really foul things up requires a computer. That's where traps come in. SNMP traps are like little alerts that our devices send us when something's amiss. It's like a smoke detector going off, telling us there might be a fire. These traps can tell us all sorts of things, like if a link goes down, a device overheats, or if someone's trying to hack into the network. But traps are only useful if we know what they mean. That's where OIDs and MIBs come in. An OID is like a unique identifier for a specific piece of information, and a MIB is like a dictionary that tells us what that OID means. And let's not forget about network device logs. These are like the diaries of our devices, recording everything that happens. By reading these logs, we can get a detailed understanding of what's going on in our network. Different logging levels let us control how much information is logged. Debug level is like having a chatty Cathy on the line, while error level is more like a terse telegram. Now, we've talked a lot about monitoring and troubleshooting, but the best way to deal with network problems is to prevent them from happening in the first place. It's like that old adage, an ounce of prevention is worth a pound of cure. One important aspect of proactive network management is understanding the environment our network operates in. Just like we wouldn't want to leave our computer in a sauna, we need to make sure our network devices are in a cool, dry, and stable environment. We also need to establish performance baselines. This means monitoring our network over time to get a sense of what's normal. Once we know what normal looks like, we can easily spot when something's out of whack. Net flow data can be really helpful for this, as it gives us detailed information about network traffic patterns. And finally, we need to be prepared for the inevitable: downtime. No network is perfect, and there will be times when things go down. But by having a solid plan in place, we can minimize the impact of downtime and get things back up and running as quickly as possible. So there you have it. Network performance monitoring. It's not just about keeping the internet running smoothly, it's about keeping the world from descending into chaos. It's about being a digital superhero, protecting the innocent from the dreaded spinning wheel of doom.